So I'm Ross Holmes. I head up the business development and sales for Arcturus, which is the penetration testing arm of the Cyberthought Group. So we are CREST and Check accredited, and essentially we have just one job, which is to test the security controls of anything that connects to the internet or has a plug on it, pretty much. Our absolute speciality and where we really excel is in the field of application penetration testing. And we have some of the most talented penetration testers, ethical hackers, some people call them, in the market. We have Alex Main on today, who is going to talk to you about Agile security. So over to you, Alex.
Thanks, Ross. Hello, everyone. I'm going to talk to you about introducing security into an Agile software development lifecycle. So to start, I'll start with introductions. My name is Alex Main. I'm a senior security consultant, essentially a penetration tester by trade with a distinct focus on applications, do it all, so web, mobile, stick client. I've also been a developer in various projects, including one of our software as a service products called Oversight, which provides continuous monitoring of your internet-facing perimeter with regular scans to detect new vulnerabilities as they are exposed. As soon as an issue is exposed, it will alert you to issues that arise on the perimeter, and it focuses on identifying the high-risk issues that directly impact your business. So I'm used to working in a software development lifecycle. I understand Agile and I've used it. So what we're going to talk about is this. So why should you care about security? What's your understanding of what your current process is? Introducing security as a process, security automation, breaking the build, when to penetration test, understanding the risks, and applying realistic first steps. So why should you care? Everyone's favorite 4-letter initialism, GDPR. So everyone's liable to fines and sanctions if their data gets leaked that they store. So GDPR has a high expectation of security. So Article 32, the security of processing, requires organizations to implement technical and organizational measures to protect the rights and freedoms of data subjects. That means you need to be able to demonstrate that you're taking security seriously, and the implications if you don't are sanctions and possible fines. Then there's Article 25, which is the data protection by design and default. This requires that you think about the way you design your products and services in a way to ensure that that data is protected. So by coding securely, this is a great way to demonstrate compliance to this article. So your users expect you to be secure. So users are naturally trusting. If they're giving you their data, they're assuming that's going to be kept safe and sound and nothing bad is going to happen to it. You should adhere to that and make sure that it is. Your reputation shouldn't be at risk. So any breach or incident could and will affect your users' trust and your reputation. And I've heard of many different instances where though a data breach doesn't sink a company because the fines don't destroy them, the lack of business and the loss of business affects them, and then they eventually have to shut down because customers don't trust them anymore to store their data, so they vote with their wallet and go elsewhere. So additionally, like, users expect their data to be private as well as secure. So information security should be a priority. Everyone's obliged to protect customer data, and with the ever-changing threat landscape and data regulations such as GDPR, there's a Data Protection Act, Computer Misuse Act, lots of lovely regulations. So what is security testing? So security testing just tests, unsurprisingly, the confidentiality, integrity, availability, so that's called CIA, authentication, authorization, and non-repudiation. So confidentiality is making sure that things are kept to only the people that should be able to see them. So only you should be able to see your data. No one else should be able to see your data. And that's what confidentiality entails. Integrity is making sure that data A, when sent across to point B, stays exactly the same. It doesn't change and no one can change it. So if I go to facebook.com, when I go there and make sure that it doesn't get changed to evilfacebook.com, that then steals my passwords, for example. Availability, so is it available when and where I want it and when I need it? So any downtime, denial of service, anything like that. Authentication is the process of logging in, essentially, so proving that you are who you say you are, and like making sure that it does work, making sure that other people can't log in as you, and there is something that irrefutably defines who you are. Authorization is what you are supposed to do. So a simple low privilege user may be able to read the website, and then an administrator may be able to change it. And it's making sure that the people that aren't authorized to change the website do not have the ability to. And then there's non-repudiation, which is more of a legal term, and it's the assurance that someone cannot deny the validity of something. So it's a legal concept that's widely used in information security and refers to a service which provides proof of the origin and the integrity of data. In other words, non-repudiation makes it very difficult to successfully deny who or where a message came from, as well as the authenticity and integrity of that message. So a common example of that is signature, for example. So this is Agile development in a nutshell. Nothing matters, cover everything in duct tape, get everything out the door as quickly as possible, and just fix it as soon as. So even in Agile development, classic testing strategies follow the waterfall project delivery model. So requirements, design, implementation, then verification where a security test happens, and then maintenance. So oftentimes you'll just do a penetration test once a year or something along those lines, and it's not integrated into the actual development lifecycle when large changes happen when you're releasing version 2.0, for example. So you're testing after the delivery of a product, but hopefully before the actual deployment, within a set scope, i.e. only the product, and within a limited time frame before the release date, and limited resources. So this often leads to things like a time crunch. So you end up prioritizing individual tests, and features end up being left untested. There's oftentimes like a limited security assessment. So the product is not necessarily assessed in its final environment, in its final stage. It's often done in like dev or UAT. There's oftentimes not enough time to test as well. So if you say, oh, I hear this a lot, oh, we're going live in 2 weeks. Like, can you test us next week? What happens if there's a fundamental and critical flaw that is found that is core to your product? Like, can you push the deadline? So making sure you do the testing at the appropriate time and throughout is really important. Sometimes there's just no testers available, or they're just not ready or able or willing to do the testing, and they are a limited resource. And then there's no time to fix things, to feed back into the software development lifecycle before it goes live. So there's lots of reasons why security and Agile don't mix on the surface of things. Oftentimes people think, for example, or there's a vague assumption that the Agile project is capable of translating the generic security requirements to specific controls. But this unfortunately fails because the Agile team often has other priorities. They have limited resources. There's a strict timeline, and like understandably, the Agile team can find security boring. It's hard and it's difficult, and doing things the right way is not always the easiest way. And sometimes the easiest way is the most satisfying way to do things, but that's not always the way to go. So another assumption is the Agile team have the expertise and knowledge to build secure solutions. So this fails because the Agile team often don't have the skills or the expertise necessary to fix or identify the issues. The Agile team may not be aware of the requirements or the security requirements because it's not like given clearly enough. They may not be aware of the actual security vulnerabilities themselves, so they may not know of very niche and specific vulnerabilities that they just didn't know existed because they're novel and obscure. And they oftentimes don't necessarily have the tools or the methodologies to follow to understand what security best practices there are and how to fix them. So another assumption might be there's sufficient time and money to perform a security test and process all of the recommendations before release. So this fails because continuous delivery has no clear test phase. There's a focus on functional testing, which makes pragmatic sense. It needs to work before you can test the security of it. And because of the way that the Agile software development lifecycle is, there's constantly a shifting focus, which is only really clear at the start of the sprint, but a year down the line, a month down the line, things change. Everything is always a bit up in the air. So another assumption might be there's sufficient time and money to identify and address all security risks. So this fails because there are serious time constraints that projects need to get delivered. There may not be enough people or resources, and oftentimes there may be a cultural clash between Agile and like the Agile software development lifecycle and slowing down to identify and address all security risks. So this is generally how things start and how things come along in the sprint, and then the delivered product never ends up exactly how it intended. So in the rush to deliver functionality, most agile teams lack thought about security, and then there's gaps and there's holes in the delivered product. So general failings. The agile team often don't have security skills or expertise. You constantly need to make sure that there is a baseline understanding, education, and experience for security. So education should be frequent and often. So as a penetration tester, I'm spending at least 4 hours a week reading up on new vulnerabilities, new techniques for attack and things like that. So it's understandable that developers don't have that skill, don't have that expertise, and don't have the time to keep up with the ever-changing landscape of security, but they should have a significant, everyone should have a baseline knowledge of security. So you only need 1 weak link in the chain for everything to come down and collapse. So it's making sure that everyone knows the fundamentals and isn't making any obvious and silly mistakes. So making sure there's an awareness of security requirements. So when you're in your daily stand-up, making sure that everyone is aware of what security impacts there could be, making sure there's security user stories, the appropriate policies and frameworks to make sure that everyone is aware and understands the security requirements. So again, having an up-to-date knowledge of security vulnerabilities. There's also not having the right required tools and methodology. So with the tools, there's lots of automated tools that you can use that can tick off the difficult, sort of some of the easier to find vulnerabilities, and making sure that people are following best practices and there's no glaring obvious holes. And it's making sure that those tools are used, implemented and read properly and well, which is a different challenge in and of itself. And then certain methodologies, so following the right frameworks of keeping things secure and making sure they work well. So then having a sufficient time, especially no defined test phase. So integrating security at every stage in the Agile software development lifecycle is really important. It's making sure that it is in the forefront as much as functional testing and as much as getting it actually working. Having it not count, having it not released, the product isn't viable until it is also secure. And that can be a bit of a culture shift. So the first step is to understand your current process. And to do this, you need to ask yourself a lot of questions. So first, understanding how your development team is organized with developers, testers, architects, chief security officers, etc. Are they distributed? Are they co-located? So what is your Agile software development process? So write it up on a whiteboard, understand what practices you adopt, whether Agile or Lean or whatever. So how is your security engineering process organized? How is it managed in your team? Like, for example, what security requirements do you have? Is there secure design, secure coding, security testing? And can you describe how you organize your security testing? How are incidents and security issues reported and managed? This reminds me of one of my favorite stories, or if you fire your information security officer, you will reduce the number of security incidents that you have. But that's because people aren't watching. If you aren't aware of these things happening and you just bury your head in the sand, then you won't know. And GDPR is there to catch you out and punish you for doing that. So you can't do that anymore, and you need to make sure that your software is secure. So can you describe the kind of security testing that you perform in each testing phase, and make sure you've got a process for back end and front end? So there's various phases of testing. So you've got unit testing, which tests classes, functions, statements, data, and that's for individual modularized packages. Then you've got integration testing. So how do the modules and packages work together? So once you've unit tested a function, how does that function work in the grander scheme of things? Do they all work together? System testing, which is testing the entire system, top to bottom, making sure it all works. Regression testing, so making sure that any changes made aren't reverted. So if, for example, I find a cross-site scripting vulnerability in one page, getting it fixed and then implementing a regression test to make sure that if someone deletes the fix for whatever reason, that reappearing vulnerability is fixed and is brought up, and people are like, okay, no, this doesn't pass anymore. Then you've got UAT testing, so user acceptance testing, which is just making sure that people can use it, and it's similar to system testing. And then you've got production and configuration testing, where you're testing it in production, everything works properly. So then there's four types of testing in in this root cause taxonomy. So you've got analysis, design, development, deployment, and maintenance. So in the analysis and design phase, where requirements and design models are made, you've got model-based security testing. So with model-based security testing, it's providing a model and then understanding it and testing it. But you don't have, because you've only got the analysis and the design, you can't necessarily break it. You've got nothing to actually test at the moment. So it's conceptually testing the idea. Then you've got code-based testing and static code analysis in the development part. So that's actually testing the code. So getting the code, reading it, performing code reviews, for example. Then there's penetration testing and dynamic analysis in the deployment phase. So once you've got a functional unit before it goes to production and into the running system, you test it using dynamic tools as well as from an independent penetration testing company. Then the maintenance phase, so once it's up and running and fully in production, there's security regression testing. So making sure that nothing goes back to the way it used to be when it was less secure. So you need to understand all of these types of testing and implement security at every single stage of analysis, design, development, deployment, and maintenance. And each of those has a different function and a different unit. So you need to understand like how often are security testing and security related activities done in your agile cycles. So do you do it every week, every month, every quarter, every year? You need to know where you are before you can improve. So how do you decide when to perform security tests, penetration tests, model-based security testing, all of that? How do you decide when not to perform them? Like when is it useless? Like, so it's good to know when it's useful and when it's useless or doesn't provide as much benefit. Do you see benefits of performing security testing? So if you're spending a day a week performing security testing and you're not getting any real benefits out of it, maybe you need to pivot. Maybe you need to come up with a different strategy that provides more bang for your buck as such, because at the end of the day, like, you're a business and you need to be functional, useful, and profitable. So with test automation and continuous integration, do you automate your testing activities? I strongly recommend you do, and recommend that you should, because you want to take as much work as possible off of the developers' backs. You don't want them like getting stressed about security, having security fatigue. You want it to be an easy, everyday process that is seamless and streamlined, and that's what this talk is essentially about. It's making sure that you get buy-in from management and making sure management push security down from top down without adding any additional work. So automating as much as possible, just putting in as many different tools and facets to make security as easy as possible at the end of the day. And then also understanding like how to incorporate security testing in the process. So actual penetration testing. So major changes yearly, testing the infrastructure as well as the application logic, lots of different things, because there's only so much that a automated test can do. You need someone to look at the logic of applications and understand what could be done wrong. So for example, you can't automate an HR app. You can't automate a test for an HR app that you can actually approve your own expenses, because you can't automate the fundamental understanding of an application. Whereas a human can go, oh, what if I try and approve my own expense? Oh, that worked. That shouldn't have happened. Yeah. So model-based security testing. This is where you get models of an attacker, which encode an attacker's behavior. So the data that they need and different steps that they take, the way they craft exploits. So this is threat modeling essentially. So attacker models can be seen as models of the environment of the system under test and knowledge about targeted vulnerability, which is usually left implicit. So in contrast, models of vulnerabilities explicitly encode weaknesses in a system or a model of the system. In this sense, they can be seen as faults that are used for generation of good test case generation. Finally, there's properties described desired characteristics of a model or an implementation, and they include confidentiality, availability, integrity, and so on, as mentioned in the previous slides. And then models of properties are needed to describe the properties of an asset that's supposed to not be violated. So to summarize, that's making sure that you are modeling attackers' behavior, you're modeling vulnerabilities, and you're modeling the implementation of the software. So this is all the places where you should consider adding security in the Agile software development lifecycle. So introduce a security expert in your development operations and/or DevOps team. So making sure that there is someone there that's a security champion as such. There should also, so definitely get one in the development team as well. So for example, consider moving them around every week. So every week in your team of 10, one person is there to champion security. And in your daily stand-ups, making sure that they're like piping up about security, any security issues that may occur, and then that gets security into everyone's mind. And by being forced to be the security champion, they are aware and willing to take security seriously. Introduce security-related user stories. So this is B, which implement business drivers and security risks and compliance duties. So security-related user stories might be. I own Facebook. I don't want someone to be able to download everyone's data that I hold secure, for example. Include the results of risk analysis performed in the definition of ready, and facilitate that with security policies that people are actually going to read. So if you write a 300-page security document, no one's going to read it, no one's going to remember it, and no one's really going to care. It's going to be a massive pain. So instead, if you can summarize that and condense it into a 4-pager, something like that, which really gets the key clear points out, you are going to have much more luck with security and with people taking and implementing security. You need to do your best to make security fun and interesting, because at times it's not. It can be a pain in the neck, it slows things down, but it's important, and GDPR has made it doubly important. So you need to make sure that it gets taken seriously. So constantly test security and do your best to take it off of the developer's plate by automating as much as possible. So do as much dynamic and static code analysis as you can, and loads of automated regression tests, anything like that. So for every vulnerability that is found in a penetration testing report, write a test case for it, write a regression test for it, and write security-based user stories that define the risk of the vulnerabilities found to create a proactive feedback cycle to educate developers as much as possible at multiple touch points. So it's really important that a vulnerability doesn't get reintroduced elsewhere throughout the application. So you actually using penetration tests to feedback to developers to use the test to make sure that they can then write their own tests that prevent vulnerabilities being reintroduced, will give them a deeper understanding of the vulnerability, how it came about, and will sort of proactively feedback to make them much better developers or much securer developers. So make sure you've got security requirements as part of your definition of done as well. So it's very easy to just sit on definition of done as like it works, it is functional, it can do this, when I click this button, this happens. But it should be when I click this button, this happens, and nothing bad happens as well. So it's making sure that at the end, it's finished, it's functional, and it's secure, and that is defined in the definition of done, specifically in security requirements. And this is for both the sprint and the release. And then continuously monitoring your production product. So forming independent penetration tests, and then using those independent penetration tests to feed back into security related user stories. So in the executive summary, penetration test will hopefully give you a good understanding of what your risks are, what your your quick wins and longer term strategies for making your applications more secure are. So if you then take that executive summary and then place that into user related security stories, you then gain lots more value from penetration tests and from the report. So next, the Microsoft Security Development Lifecycle. It's an established security lifecycle for software development projects. It pursues the following major principles. So secure by design. So is security built in? Is security a built-in quality attribute affecting the whole software cycle? Security by default. So software systems as constructed in a way that potential harm caused by attackers is minimized, e.g. software is deployed with the least necessary privilege, so the principle of least privilege. Secure in deployment. So software deployment is accompanied by tools and guidance supporting users and or administrators. And you've got so a CI/CD pipeline with as much automated and security testing done as possible. And then security in communications. So software developers are prepared for occurring threats. They're communicating openly and timely with users and or administrators. It's important that people feel comfortable communicating about security issues. If like a very junior sysadmin notices that someone has logged into their main server and is stealing their data, you don't want them to feel scared or worried about reporting that upwards. So making sure that the communication of security is free and available is really important, and open. And it being timely as well is also important. So the security development lifecycle is composed of security practices attached with the major activities of a software lifecycle. So the security practice establishes security requirements, is attached to requirements analysis, use threat modeling to design, perform static analysis on implementation, and perform fuzz testing to verification, and certify release and archive to release. So then security as a process. So you've got security in code development. So keeping security as simple as possible and removing any unnecessary load from the development team is important. So being part of the process. So security requirements should be considered as development checkpoints. So each benchmark should be achieved before proceeding to the next stage of your Agile software development lifecycle. For each step in Agile, associate a security milestone that needs to be achieved. So start at the post-release planning to perform a security high-level design, which should include the following aspects. So security in code development. For example, inspect the planned applications in terms of which APIs are going to be used. Security in technologies, identify technologies that are going to be used. For example, if system testing is performed within a Maven process, security tests should be integrated within this system. And then security in features. For example, forecast any problems associated with regulations. Say when tracking cookies are used within a product delivered to the UK, then prepare compliance to UK privacy regulations. So security automation, these are examples of security frameworks. So Burp Enterprise is a great dynamic code analysis tool. It's good for web applications. It'll go in, enter data at various points and then see how it goes through the network. HDiv and the OWASP dependency check also work. Then you've got linters like Python taint and Python delint. They are useful for making sure you maintain good code quality. SonarQube and Veracode are, SonarQube is a good static code analysis and Veracode is dynamic code analysis tool. So these tools are all really good, all really useful, all have a great place in the software development lifecycle, but it's really important that you know how to use them. So knowing how to understand the output and effectively implementing solutions. All of these things are hard. I, as a security engineer in my day-to-day job, I sometimes struggle and I know the ins and outs of security like in detail. So having developers know it, understand it is a challenge, which means that education is incredibly important. And you need to make sure that these tools are set up and managed well, because you don't want false positives constantly winding you up, and you don't want lots of things that aren't necessarily an issue that they're bringing up. So it's making sure that the tools are developed well, are used well, implemented well, and understood well. So static code analysis. It can find a variety of issues in code, both security and structural. So it's good at forcing certain coding styles and is a fast and easy way to find errors. Oftentimes, however, these issues can be false positives, and static code analysis, sometimes it misses the woods for the trees. So static code analysis should be used continuously throughout the project, day in, day out. It should be personalized to each project to remove, for example, nuisance false positives. Again, it's all well and good understanding these tools, but knowing how to use them, understanding the output, and effectively implementing these solutions is hard. So making sure that there's constant checkpoints and people are constantly educated. Then you've got dynamic analysis. So this finds issues that are too complex for static code analysis. So what dynamic analysis does is it analyzes applications during their execution. It helps in identifying weak areas in a runtime environment. If you have a web application, for example, it will run tests as if it was a user actually on the application itself. You don't need to code to perform sorry, you don't need the code to perform dynamic code analysis. Again, it's all well and good using these tools, but knowing how to use them, understanding the output, and effectively implementing the solutions is hard. So with our penetration testing reports, we make sure that everything is as clear as possible, because even for the technical findings, we understand you guys are developers, not security engineers. So make sure it's as clear as possible. You've got an easy way of understanding what the issue is, understanding how to fix the issue, and understanding how to test to make sure that the issue has been fixed properly. Is really important. It's what we struggle to do. We struggle constantly to make sure we get it as clear as possible for you guys in our penetration testing reports. So suggestions for daily automated security checks. So source code security checks for dangerous programming logic, processing undefined variables or unsanitized parameters. So essentially just checking that no one's doing anything obviously dodgy with the code. Checking on security functionality. So does logon work? Is the authorization model correct? Can unauthorized users perform administrative functionality? There's also testing for common abuse scenarios. So does SQL injection work? Does cross-site scripting work? Can someone steal your session somehow? And just making sure that these paradigms are thought of and they're implemented, and you've got someone. So as I mentioned before, you can have a security champion. So if you've got that person maybe spending that week designing security checks and balances, tests for cross-site scripting or SQL injection, so that as time and the application develops, it's becoming more and more secure, and any security vulnerabilities are getting picked up before it even goes to production or to live, which makes the build fail. So breaking the build, somewhat of a contentious issue sometimes. So ask yourself, when do security issues break the build currently? Do they break the build? Have you ever broken the build before because of a security issue? If so, what were the reactions of the project managers, product managers, and senior managers? Were they okay with it? Did they fight back? And this is really important to make sure that senior management buy in. So making sure that they understand, and implementing security in an agile software development lifecycle just won't work unless you have buy-in from senior management. So when should you break the build? For me, my recommendation would be for any medium risk vulnerability or higher, but you have to consider what your risk appetite is. So a brochureware website, probably okay with the odd medium risk. You should aim to get it fixed, but if you've got higher priorities, then so be it. Whereas an application that handles financial data, it may be worth breaking the build for low risk vulnerabilities as well, because you do not want to have any form of vulnerability at all, because they can compound, and they can compound quickly, and it can lead to serious issues. So evaluating risk. So there's CVSS scoring. This works as so there's multiple different options you can choose. So the attack vector, network, adjacent, local, and physical. So network can it be done across a network? Adjacent, can it be done on an adjacent network, on a local network, or with physical access to the device? Attack complexity, bit of a wishy-washy one, low and high. So how difficult is it to do? I like to think of it as, could anyone do it, or could the NSA do it? Only the NSA do it. So if you need like £1 million worth of computing power, then the attack complexity is going to be quite high. Privileges required, none. Anyone can do it from an unauthenticated or unauthorized perspective. Low, you need to be logged in, but you can be logged in as any user, for example. Or high, where you need to be logged in as an administrator before you can perform this attack or this vulnerability. User interaction is like, does someone need to interact? So for example, if I set, does someone have to click a link that I send through before it becomes available? Then you've got scope, changed or unchanged. So when a scope is changed, it means like if you can hack a website and then get into the database, for example. So you've changed, it's not the greatest example, but you've changed from the website to the scope of the database. Or if you hack a database and you get access to the entire system or the entire network, then it changes the scope of the attack. So it allows you to automatically pivot to a different point in the network or a different application. So then confidentiality, none, low, and high. So confidentiality, integrity, and availability, as discussed earlier. You've got none, so there's no effect on it. low effect, which means you may not have control over what you can expose or what you can affect the availability on. And high is usually complete confidentiality breach, integrity breach, or availability breach. So this is a means of evaluating risk. It's not the only way of doing it. There's other systems and methodologies, but this is the way of doing it. This does work well for applications. It's not as great for infrastructure, but it's a nice means of understanding ranking risk and figuring out which issues you should fix in what order. And then it gives you a calculated score out of 10, where 10 is the most critical. And then it goes critical, high, medium, low. So any score lower than 4 is low. Any score higher than 4, but lower than 7 is medium. Any score higher than 7, less than 9.5, I think, is high. And anything higher than 9.5 is critical. Training. This, I bang on about this a lot, but training is really, really important. It's understanding how you keep up to date with the ever-evolving security landscape. There's new security vulnerabilities and means of hacking coming out all the time. And it's difficult for me to keep up, and it's like, it is my job. So making sure that your entire team is fully qualified and meets a certain and specific minimum baseline of security. So constant and frequent training of all current staff, but also new staff. So if you've got a development team of 20 odd developers, then there's going to be a churn of like 1 or 2 developers joining and leaving every year. So when these new people come on, how do you make sure that they meet a certain baseline? Do you train them in security? Do they have to go through all your coding practices, all the coding styles, and all secure coding practices and styles? It's really, really important, because there's just one weak developer that doesn't quite know about security, that introduces one vulnerability into your application that can just act as a house of cards and bring it all down. So it's really important to make sure that people are trained constantly and frequently, and to a set minimum baseline that you are aware of and you can prove is set. So then the methodology is the OWASP Top 10. It's a great resource. It lists all common and prevalent threats. It's got loads of good information, covers nearly all of the most commonly found vulnerabilities, and it's a really good start. So it's broken down into 10 vulnerabilities. So injection, broken authentication, sensitive data exposure, external XML entity attacks, broken access control, security misconfiguration, cross-site scripting, insecure deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. It goes into a lot of detail about all of these vulnerabilities, and there's loads of prevention cheat sheets, there's attacks explained, there's poor implementation examples as to why the vulnerability is there, how to identify it, and then how to fix it, which is great for developers, and it's got multiple languages, PHP, Java, etc. I use it all the time, and it's a great resource. If you don't know about it already, I highly recommend you check it out, and you get a good solid foundational understanding, because it's a great place to start. It's not the be all and end all, and there is lots of stuff that isn't covered, but it's great tool that I can't recommend enough. So security related user stories. So this is for like when for your daily sprints or your weekly weekly, monthly cycles and releases. So what user stories could you implement for you guys? So as a senior manager, making sure that customer data is restricted so you don't risk the GDPR fine. Or as a customer, I want to be sure that credit card data isn't exposed and it's stored securely, safely, and it's not accessible to third parties or hackers, etc. It's really useful as an exercise to do this as well. So understanding, it helps you sort of visualize and understand what security risks there are and managing the risk and what is most important to you as a business and as a developer, as a senior manager, as a customer. So looking at it from every perspective really helps conceptualize where your risks are and where you need to pay most attention. Penetration testing. So when do you penetration tests? How often? How do you action the reports and the scope? So I would recommend penetration testing but it's not feasible to penetration test day in, day out, every single day. You just don't have enough time, you won't get anything done. What I would recommend for penetration testing is definitely doing an annual test from a feasible perspective. Do an annual test, and also any major change. So have you implemented a new function? And it's really important to develop a good relationship with a penetration testing company, because they will understand the application, they'll be able to get to know it, and instead of getting fresh eyes on it every single time and say, all right, we've kind of kept all the functionality of the application the same except for the user management functionality. So how long will it take to test that? Now, one, we'll know straight away, so we'll be able to scope it up quickly. Two, we'll be able to give you the best value for money because we understand how the application works already. So we'll be able to funnel all the data into the user management functionality. And it just is really important to develop a good relationship with your penetration testing company so that they can just provide the best service for you and they can understand your application and get it done properly. So understanding how to action the reports is really important as well. So it's all well and good getting this piece of paper that says you're mostly fine, but you've got this, 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 and this issue to be addressed. I see it quite frequently where people are just doing a tick in the box exercise, and the next year the penetration test comes around and they haven't really changed anything, they haven't really fixed anything, so they're not getting the value out of the test that we want them to. And it's really important for all parties involved, for us and for them, that people read the reports, implement them, and implement the fixes themselves. So understanding the process for fixing the issue and also implementing regression tests. So this vulnerability was here, there is a cross-site scripting vulnerability here. How did that come about? How can I make sure that doesn't happen again? And how can I make sure it isn't reintroduced? And that's by writing tests that break the build. So you fix the cross-site scripting vulnerability, you also introduce a regression test that makes sure that vulnerability isn't reintroduced. Then someone, for whatever reason, changes it back and then tries to send it off to be built. Then in your CI/CD pipeline, you can say, no, absolutely not. This breaks the build. You need to fix this. This is currently vulnerable. And then there's no additional overhead. The security engineer is your developer is then okay, I need to fix this. I'll get this done. And then everything happens without any additional thing. And then the question of scope is important. So again, this is why it's useful to have a good relationship with a penetration testing company. What should be tested? What shouldn't be tested? Well, everything should be tested, but sometimes due to limitations in money or time, you can't test anything. So then defining what is most important to test, and also what avenues you're most concerned about for testing. So are you concerned about someone that can log in? Can they then see someone else's data? Are you concerned about someone hacking you without having any login information? Where's the risks to you? What are the concerns for you? So incident handling is necessary to catch all things that slip through the cracks. It's not an omission, but a result of the fact that you cannot test and secure everything all the time, always. Security is an ever-changing landscape. If someone has a 0-day, there's not much you can do about it. So all you can do is prepare yourself. So it's not a case of if, but when. So it's best to be prepared for when an incident occurs, so you know what to do when the time and the pressure comes. So we sometimes perform war games where we turn up to the board, hand them an envelope and say, okay, you have your entire backups have been hacked, they have been deleted, and they're threatening to take the website down. What do you do? And then it's just going through the process, finding the weak links in the chains that, you don't realize that you need to call Barry in the data center to get the offline backups or something like that. So it's understanding who to report the incident to, what the impact is, escalation and resolution, monitoring for incidents, and also lessons learned for the post-incident review. So all this is well and good, but actually implementing practical first steps is really important. Change is hard, transformation is hard. So trying to come up with a practical initial means of implementing security into the Agile software development lifecycle is important. So a question that is worthwhile asking yourself before you get started is, what are the main reasons that cause security to be less of a priority at the moment? So as I mentioned before, implementing a security champion to create a system where a developer every week is defined as a security champion. They're responsible for making sure security has a voice. Implementing a culture of security first. So you've got buy-in from management, making sure managers, including project and product managers, have buy-in where security is at the forefront, security first. And I think to get this change started is to start small but think big. So many of these practices, especially the practice of breaking the build for any high or medium finding, requires the management and superior support. So we recognize that getting this type of trust is not an easy goal to achieve. So various companies have found the following steps helpful when we've helped them implement security as best practice in their agile software development lifecycle. So taking one small project and turning it into a success story. So instead of going for that big legacy behemoth of a project, start off with your small brochureware website, for example, and then take it into account, implement security first, implement security user stories, have a security champion as the developer, and listen to the moans, gripes, pain points during this process, learn from these mistakes and refine the process moving forward. So there is no one size fits all. Everyone's agile software development lifecycle is slightly different. There's various nuances in agile as well. So there's different sections or subsections of agile. So no one size fits all. So when you get one success story under your belt and you've worked out or eked out all the pain points, move on to another project and continue refining, see if there's any more pain points, any more nuances or nuisances, and learn from those mistakes. Create 2 to 3 project success stories, and then review the security bugs that are returned by customers, by penetration testers, and compare the number of vulnerabilities in one of these success stories with a different project that does not follow the security best practices. And that gives you concrete proof that what you're doing is working and it is successful and it should be implemented company-wide. So then when you show management how vulnerabilities interfere with the normal delivery and maintenance of the product, you'll then get more buy-in and things will start to go easier. Security first will become at the forefront of everyone's mind. And you can also presumably find a decent amount of business benefit. So if a big security vulnerability happens, it pushes version 2.0's delivery date 3 months behind, because then you show that one of the success stories has been on time for the past 6 months. You then get a lot more management buy-in and things will start going quicker and quicker. Eventually progress to your big legacy project. So at first, don't break the build for this big legacy product. That every company has a behemoth. So don't break the build for the security findings in this big project straight away. It's enough at the beginning of the stages to identify the gaps, close them, and create a program of how development will fix the flaws. So fix the flaws on the legacy systems only after understanding how to correctly deliver the security package, how to inspect it correctly, and where to correctly apply the validation without any impact to the product. And then proceed to the big project in making. So naturally, this is the ultimate goal and security should already be integrated within the agile process. At this step, the validators should already be packaged and set within a single framework, and everything should be working and hunky-dory. This is often a slow burner, and it takes a lot of concerted effort and lots of small changes, but they do build up and it does work. And then you can remodel your agile software development lifecycle to implement and integrate security at every single stage. And that's really important to make sure that it's at every single stage, so it's always at the forefront of everyone's mind. So an overview. So security should be a part of each of the entire process, with security in code development, security in technologies, and security in features. Automate as much as possible, use static and dynamic code analysis, and integrate tests into your CI and CD pipeline. Take as much weight and work off of developers as possible. It's really important because you don't want them to get security fatigue. You don't want them to get annoyed, and you don't want to affect their morale. You want it to just be a streamlined, simple, easy process. And for every security finding you make sure there's a regression test to prevent it being introduced again. And also do your best to make sure that these tests are as broad as possible. So if you find one cross-site scripting vulnerability on an obscure page on an obscure page on the application, can you write a more broad, global, generic test that will test every single input for cross-site scripting across the whole application. The broader and more generic you make it, the less issues you will have in the long run, and the more frequently it will find things, and the better you'll be. Eventually, start small, plan big, have a security champion, and make sure you train your staff frequently to a set baseline. Yeah, that's it. Thank you very much.
Thank you very much, Alex. Just had one question that was emailed in from someone who signed up. While we ask that and Alex answers, if anybody else has got any questions they want to just sneak into the Q&A box on here, then we can answer them before we sign off. Quite an interesting question to ask a penetration testing company. We're asked, do you think that penetration testing should be made compulsory for SMEs?
From a penetration testing perspective, I think penetration tests should be made compulsory for all software, full stop. If it's holding customer data, it should be tested, it should be security tested. Even like setting up a dentist office or like a pie shop, they should be sure that all the data that they've got is secure. At the end of the day, there's different levels and different varies, and it's just understanding your risk appetite. But I really do think penetration testing is really important. It's great to have an independent view on where you are with security. And also, just by getting penetration tests, you're saving yourself money in the long run, because if you do get breached and data is stolen, you have to report it to the ICO, and then GDPR will lay down the hammer with you with, I think it's an £800,000 fine or 4% of your gross profits, whichever is more.
Thank you very much, Alex. I think just to add to that, is, like you say, if breach, the first question they're going to ask is, have you taken all reasonable measures to protect yourself and your customers' data? And the NCSE themselves, they actually list penetration testing as point one that you should do to make yourself secure. So while mandatory or compulsory might be a bit of a strong word, but it kind of already is if you're holding or looking after anybody's critical or anybody's data, really. Absolutely, very good point. Just to add to the presentation that Alex did, thank you for that. We at Arcturus run a 2-day secure coding workshop where Alex's team will get the company's development team in a room for 2 days and essentially teach them how to hack, I suppose is the way to put that. They run through the OWASP top 10, all the kind of usual things that they find when they're doing a penetration test, but also some of the less typical things that they find. Any of our clients that have been through this 2-day workshop have said it's been absolutely the most valuable thing that they've done, and it's significantly reduced their testing cycle, and certainly anything that Alex and the team have tested after the guys have been, or a team has been on this coding workshop, you know, the findings are significantly reduced, and you know, it's proved very valuable. To that end, we have created a series between now and the end of the year, so one a month, of completely free workshops that you can send any of your development team along to. Like I say, they're completely free. We're doing one a month on a subject like cross-site scripting or fuzzing, etc. So you can find all the details of that on the URL that you should see on your screen, which is live.cyberfortgroup.com/events. So if you are interested in that, then drop along to there and sign up. I think they'll be very valuable for any development team that you have. Other than that, I think that's it. Thank you very much for tuning in, and I'm sure we'll see you soon.